In this video, what we're going to do is create a noise-like scene, sort of like Minecraft, using three.js, and I'll show you all the basic steps to get that set up. So the first thing to do in any kind of modern web project is to use Node.js to install packages. And to that, we go to nodejs.org and then we install it. I already have it installed here on my computer, but it's an important step that we can do. The next step that we want is I want Visual Studio Code, which you can download. I already have it on my computer here. I'm going to open it up. And what I'm going to do here is I need to start this project. And in order to start this project, I need to have a folder. And in order to have a folder, I need to have a place to store it. So instead, what I'm going to do is just go to the desktop like this, open. That's going to open my entire desktop. Yes, I trust the authors. Go to terminal, new terminal. And here in this terminal, I can now type a bunch of commands that allow me to create a test project. So I'm going to put it on my desktop and it's going to be called Noise World. And what I'm going to do here is use a tool called Vite to create this. So the first thing I have to check is if npm is installed. So if I type npm, I get here a bunch of help files, so that works. And then I'm going to write npm create Vite add latest, so the latest version of Vite. It asks me for the project name, so I type Noise World. It asks me if I want to use a framework. I want to use plain JavaScript code, so I write vanilla and JavaScript. All right, and that's done. And now it says, now run Noise World, npm install, npm run dev. Now we'll do that, but instead what we're going to do is go to here, file, open, select this folder, and now we're opening that folder. And then we go to terminal again. Now we're in the right folder, and this is the main benefit of using it this way, is that we now are in the right folder. So now we can write npm install, that's going to install all these packages, and then npm run dev. This is a very, very basic setup. So if we now control click or command click on this link, we open that up in our browser. If this opens up in a different browser, it's actually useful to use Chrome or Firefox to develop with that. And you see this is a very basic example that we get for free from Vite. We can already put this into version control. So here in the sidebar we can do source control, initialize repository, and then we can take all these files, press plus here and say initial commit. That allows us to put this onto GitHub later if we want. Cool. And then we can publish, we don't want to do it now, but we can publish this and put it online. Now we need an extra dependency, we need three.js, and we need our noise generator for that. So we're going to install these dependencies here. First we're going to stop the server, we can press Control-C, so not command, but control. And then here we can type npm install, and then the packages that we want. So the first package that we want is three.js, which is just called tree, as you can see here. And then the second package that we want to install is this tree noise, which is just like this, tree-noise. So like this. And type enter, that's going to install these two packages. And then I can type npm run dev again, which I always have to do if I want to start the server. Now this doesn't change anything, our scene just looks exactly the same, but what it does is it makes sure that these packages are available for us. So let's look at the project structure here. We have our index.html, which is just a regular page saying Vite app with an app block here, and then a module with the main.js. We don't actually need this app here, so we're going to remove it. What we also don't need here in the main.js is basically all this code except for the style.css. We'll leave that in. But all the rest we can remove, and that we're going to replace with our three.js scene. And in order to do that, what I always do is start with this basic setup, because that works really well. So we do import star as tree from tree. We make a scene, we get the camera. So that's useful. We make a renderer. We append that to the body, and then that gives us a basic setup. Now we want to draw something. So this one we'll replace later, but for now we're just going to draw one box, put a camera somewhere, and then render the scene in an animation loop, which is this code. And then if we go look at our page, normally what we see is our little block here, which is just a block, but it's not moving, so we just see it front on. Yeah, so the three.js code actually recommends adding some rotation to the cube, so you can actually see it spin, which we can do here. What we can also do is add orbit controls, and that's making it easy for us to actually see the cube moving as well. So we go to orbit controls from tree/, and normally it auto-completes already, but if it doesn't, You can type examples, GSM controls, orbit controls. And then after we've made our scene on our camera, we can actually initialize the controls. Oh wait, we actually have to do it after the renderer, I think, yeah. Yeah, like this. And that allows us to drag the cube around, which is very useful. All right, now for the noise part. So the main idea here is that we're not going to draw one cube, but a bunch of cubes, and these cubes will be spread out according to a noise function. And so here we can see in our noise, there's this demo, and basically this is what we want to create. So we have all these blocks here, we can create them. We can actually look at the source code, and this is basically the setup that we're going to do right now. There's two ways to do this. There's an efficient and an inefficient way. The efficient way is to use an instant mesh, as it's called. So basically create one mesh, but then have all the positions where the block needs to go. The inefficient way is just to add more and more cubes to the scene. Both work, but one will render much faster than the other one. In this case, I'm going to pick the easiest option because that allows us to have more control over the scene later. And so the first thing that I want to do is initialize the noise itself. To do that, what I need to do is import our noise library here. And for that, I need to go look at the docs, which I always do. Yeah, so here it says in Node.js you can import it like this, which is what I want. Except I don't really want the Perlian noise, I want the FBM noise, which produces nicer noise for us. And now it complains that tree noise doesn't exist. That's because I think it's called like this. That should work. It's a bit weird that the documentation is wrong for that. And then we have to initialize our noise function. And we do it like this. We say const FBM equals new FBM, like this. And then here we can provide a bunch of options for it. So we can give it a random seed. So this is basically the initialization function. We can give it a scale, so how big the noise is going to be. And I take these ones from the examples. We can provide octaves, which is the complexity of the noise, or the levels of noise on top of each other. Some other values, and these are really interesting to play around with to get different values. And then the height is going to be set to 0. Now this is what's called a noise generator. It doesn't automatically produce a noise field or anything. Instead, what it allows us to do is change the position based on these noise values. That's the core thing. So we're going to give it a position and then ask the noise system, like, okay, where does this block need to go based on your noise function here? And in order to do that, we're going to make a grid of cubes. And the height of those cubes will be defined by the noise function. So to make that, we're going to add a width here, let's say 50, a height of 50. So that's going to be the size of our noise field. And then, yeah, we don't want a depth, but we want a loop through these noise fields. So we can say for let x equals 0, as long as x is smaller than width. We do the same for the height. And we call them width and height here. But you can think of them as a plane that's spread out over the distance. So maybe this makes sense to call it depth, like this. So it goes in the depth. So on the what's called the z-axis, because the y-axis in three.js is up. And then what we can do is give it a position here. And so to do that, we're going to say pos is a new tree.vector. 2, which is the position containing x and z, and then we can ask the height. We can ask the FBM to give us the 2D noise, and I think it's just called get2, I'm not sure, to get the noise value of that. And then with those informations, we can create our cube. So basically the geometry stays the same, the mesh material stays the same, but we want the position of the cube to be set correctly. So the x position, the y position, and the z position all come from the cube, and then we add the cube to the scene. All right, let's see what that does. Let's remove our basic cube here because we don't use it anymore. It's just going to be in the way. And let's see. Yeah, of course, this scene is huge because there's so many cubes, as you can see, but it does work. We get some height field here that we see happening. Maybe it sort of makes sense to make those cubes scale a bit smaller. Let's scale the cubes down and to 0.5. You can see it a bit better. And that's something that we can define. So we start in this corner, but what we can also do is change the position of our base actually to the x position minus the size divided by 2, and so everything will be in the middle. So let's try that. So the position of our cube, the x position here, is going to be x minus the width divided by 2. And for the y, we do y minus height divided by 2. And what that should do is crash. So this is interesting. If it crashes, this is something that I want to show you as well, is I can press Command-Shift-I, and then what I can see is that I get the errors here. So this is the inspector view. And this is very important to basically leave open all the time because it shows you what goes wrong and where. So here it says y is not defined, main.js at line 41. So let's go look at line 41, which is this line. And what we see here is that we're trying to do this with y, which is not very useful because we want this to be the height, like this. And then we actually wanted to do this for the z-axis, the z value, the depth. And so now what we can see is that we're actually in the middle of this noise field. We can put our camera maybe a bit higher. So now we move the z position of the camera. That's useful, but we can also put the y position of our camera a bit higher. And that allows us to sort of look over this noise field as we move along. It's really, really basic right now. There's a bunch of other things that we can do. We can do height multiplied by 2 to get some more depth in there. We can animate that if we want. But the basic steps are always going to be the same. We can also add some lights, of course, because this is not lit at all. This uses just the basic material. So there's no directional light or there's no optional light. Maybe this is something that we can add, actually. But yeah, this is maybe something for a different tutorial as well. There's one other thing that I wanted to show you, and that's the OBJ exporter. So if we have a scene like this, how do we get it out of the system? And we can do that using this, what's called the OBJ exporter. So we can do this. We can ask the exporter to export the scene, and maybe we can do this whenever we do something in our scene. So here we can do window at event listener. Let's say that we are looking for a key press, and here's going to be a function, and here we can say if the key that we've pressed equals, and they say S, which is fine. I want to do E for export, but same thing. So we make an exporter, we parse the scene, that's going to be the result, and here we print it, but instead what we want to do is download the scene. Yeah, which using this download file function, which I'm not sure exists. So let's see what's going to happen. I think it will fail. Yeah, so it says download file is not defined. Let's see if we can autocomplete that file here with the data. Because this function is really, always the same. So now if we press E, now it says data is not defined. Okay, cool. Oh yeah, because we called it result here. Yeah, cool. So now we get a scene here, and if we look at that, then we get our nice scene here. So this, with a bunch of code, we can just get our own noise field that we can export from three.js like that, and allow us to change all these parameters. All right, so that's the basics of our noise field. So I hope this was useful, and see you in the next video. Okay, so as I promised, there's some extra steps that I wanted to do, some extra stuff that I want to show you. And one is the mesh material. So we now use the mesh basic material, but there's also the mesh Lambert material, normal material, and mesh standard material. This one's pretty useful. The only difference here is with this material, everything's black because it needs lights in the scene. And so there's two lights that we can add to the scene always. The first one is a ambient light that helps just set up the, let's say, atmosphere of the scene, tree ambient light, and that requires a color like this. We also need to add it to the scene always, and then the other one is a directional light, tree directional light. And here it's important to set the position of this. So let's make it a bit bigger because our scene is quite big. And also we can add that to the scene. And now if we do, we can actually get some shading in our blocks as well. So this provides a nice basic lighting setup that we can use. Also, we've changed the size of our cubes here. We can make them a bit bigger still. So they were at 0.5, let's make them all 1 again. And now we can see that they sort of nicely match with each other. I'll do height multiply by 10 to get a bit more variation here. All right, that's it. Thanks.